Today's lesson is about correlation and linear regression. But there's a few vocabulary words we have to go over first. Correlation, coefficient of determination, slope, and intercept. So first let's go over correlation. The correlation coefficient is a statistical measure of the strength of the relationship between the relative movements of two variables, usually input, output, independent variable, dependent variable. And in this case, most of our independent variables or input are going to be x's, and the output or dependent variable are going to be y's. The range values between -1 and 1. It's a calculated number greater than 1 or less than 1 means there was an error in the correlation. So all your answers are going to be between -1 and 1. A correlation of -1 shows a perfect negative correlation, meaning the slope of the data goes downhill, while the correlation of a 1 shows a perfect positive correlation, where the slope is going uphill. A correlation of 0 means there's no relationship of the two variables at all. It's just a random scatter plot, as you can see by the pictures. This one here is negative, this one here is positive, and this is no correlation. Now, anything close to 1 or -1 is strong correlation. The closer you get to 0, the more scattered or unrelated the two variables are. Our second word is r squared, or it's called the coefficient of determination. Shows the percent of variation in y, which is explained by all the x variables together. Higher the better. So the closer to 1, the more output is explained by the input. It's always between 0 and 1. It can never be negative because it's squared. So if you have a value of 0.8 as r squared, that means 80% of the output can be explained by the input. But that also means that 20% is unexplained. So as a true statistician, if you're trying to prove something, you have to figure out why is my model 20% weak? All right. So now, this Excel regression example is in Schoology. Go ahead and open it, download it, and open it in Excel and or Google Sheets. The formulas are basically the same, and I'll show you how to use Excel to get correlation, coefficient of determination, slope, intercept, and how to put your equation together. Pause the video until you can get it open. Alright, now that you have it open, the first thing we're going to do is we're going to calculate correlation. So in this cell, right next to R, or correlation, do an equal sign, write the word correl. It could be lowercase or uppercase. Put a parentheses. Highlight all your x's. Put a comma. Then highlight all your y's. Then close your formula with a parentheses and press enter. So what I'm going to do is I'm going to open this up a little bit more, and I'm going to bring it down to 2 decimals. I'm going to do all of these 2 decimals. So 0.88, that's a positive correlation, and 0.88 is relatively close to 1. So there is a good relationship between my input and my output. So now let's see our coefficient determination. Put an equal sign, click on the cell above, do a chevron, which is Shift 6, and then put a 2. This is going to square our r. R squared is our coefficient of determination. So we want to make this smaller. Okay, so we made that 2 decimals. So 0.78. 0.78 means 78% of the output is explained by the input, which also means 22% is not explained. So if this was a mathematical model of something very, very important, something like life and death, you would want to try to get a better model because you don't want 22% failures. All right, now once we know that it's relatively strong correlated, we can go ahead and build our linear regression, our mathematical model that explains the data. But to do this, we need slope and we need the y-intercept. So our formula is over here. You can see slope. Now the tricky part here is it's x's comma y's. Y's comma x's. It's reverse of the correlation. So in the cell next to m, do equal, type in slope, does not have to be capitals. Then we're going to do y's first, y's, comma, and then our x's. And then we're going to close it off with parentheses and press enter. So I'm going to make this 2 decimals because I need to make this bigger. Our slope is 196.15. That's pretty steep. Right, now we're going to do our y-intercept. This is where our equation, if it were to go at x equals 0, it's where it would hit the y-axis. So once again, we do equal, intercept, open parentheses, we do y's first, comma, and then x's. Close your parentheses, press enter, and we have a y-intercept, make it 2 decimals, of 102.29. So this is where it crosses the y-axis. So now let's write our equation. So y equals 196.15x plus 102.29. This here is a mathematical model that describes this data. Later, we're going to learn how to use this mathematical model to figure out standard deviation and error with our data. So once you're done with this example, you're going to open up the other in our assignment on Schoology. There's another data set that I want you to do exactly the same thing. Now remember, on A days, I have office hours from 9:30 to 11. You can call me, email me, email me on Schoology if you need help with this, and I'll walk you through it. Okay?